Hello, in this video we're going to do an elimination problem, again suggested by my students. Thank you for that. So this is elimination, and actually this is E2, the problem that we're going to be looking at. So let's see what it says. The problem says S 1 bromo 1 2 diphenyl ethane. It reacts with sodium ethoxide and produces transtylbene in the cis. So this I'm going to draw in a simplified way. And because notice I have ethane, so I'm going to draw 2 carbons. And then I'm going to draw this. No, let's do another abbreviation. So the phenyl groups can be abbreviated as pH. And that means this. I'm going to draw it here. That's my phenyl group. You can write this. Or there is another abbreviation that is very, used a lot in the stat 5. So I'm going to use that. That's bromo. And I'm going to write my substrate, so 1, 2 carbons. And then I have another phenyl groups. So that's it. So notice 1 bromo, 1, 2 diphenyl ethane, and that's the S configuration. And to remind you guys how do we do absolute configuration, the hydrogen is in the back, so we have priority 1, priority 2, priority 3, so this is S. So I have the right structure. Products are, it says in the problem, and so the trans and stylbene and the cis isomers. And it also says that this is a major product. So we are going to explain how this is formed and why is this the major product, and this obviously is a minor. Okay, we're going to explain that. To do that, we need to remember that in that elimination, notice why an elimination? There is no longer a bromine and we're removing a hydrogen to make a double bond. So we're removing essentially HBr. But this elimination proceeds by an E2 mechanism in the presence of a strong base. This ethoxide is a strong base, strong nucleophile. And substrate here, notice that at where the bromine is, you have one alkyl chain, another alkyl chain, so secondary, strong base, strong nucleophile. Secondary substrate, the predominant reaction is an E2. So, but we have the possibility the substrate can react produce E2 and can also have substitution product. But when we have a secondary substrate, the major product is always the E2. So let's see, we're going to see why we form this. And then we're also going to do the substitution product. So to better understand that, we need to go to the mechanism to see why we get this. And so we need to remember that in that elimination process, the leaving group in the beta hydrogen need to be anti-periplanar. That is, opposite to each other in the plane. What is a beta hydrogen? The hydrogens are here. So here we have 2 hydrogens. So and there is to see this, better, we're going to draw a Newman projection. The Newman projection, let's think my eyes is pointing to that carbon. So this is my front carbon. And I'm going to draw my circle here. So front carbon, I see a phenyl going down, right? And then if my eye is here, to my right, I will have the bromine. to my left is not pictured, but I have a hydrogen. And I know that we don't draw hydrogens attached to carbon. So here is phenyl. And now the carbon in the back will have a phenyl up. And now I have two hydrogens, so one to the right, one to the left. Next, I need to have noticed that in these conformation is actually staggered. And it is, those two big groups are opposite to each other, so it's lower in conformation than another stagger. So lowest energy conformation. And now I am going to label this hydrogen. So I'm going to say this is hydrogen A, this is hydrogen B. It turns out the hydrogen A is just opposite to the bromine. So it is anti-periplanar, the way it is, I say, required for the mechanism. So now the base is ethoxide that is going to attack on that proton. The pair of electrons in that bond is going to make a double bond between the carbon in the front and the one in the back. And the leaving group is going to depart in a concerted fashion. So let's do another drawing of what is that result after that. So my front carbon is going to have still this hydrogen that was labeled hydrogen B. And it also has a phenyl. That's my carbon in the front. The carbon in the back is going to have a phenyl, right? And this hydrogen here. Now, this is viewing the molecule like that. I'm going to go this way. And that I'm going to draw, say that this in the front is going to go to like that. And I'm going to do a different drawing. Now, again, moving from this to that. The carbon in the front, say that it has a phenyl. This is the carbon in the front. And a hydrogen. The carbon in the back to the same side of these has a hydrogen and a phenyl. And as we can see, just to our opposite side, so that is the trans. And it is a major product because this is lower energy conformation. So in another video, I'm going to explain the other product.